the rapid prototyping machine ML microservices using Agile. My name is Jose Brache. I'm a solutions engineer here at Algorithmia. And today, we're going to discuss what Algorithmia is and what type of problems we help you solve. I'm a solutions engineer, and I really help our customers productionalize their machine learning initiatives and take their models from concept to production. And we help facilitate that. So, I'm going to walk you through what Algorithmia is and what type of problems our platform helps you solve. We'll walk through a solution example demonstrating how data scientists and engineers can work with Agile principles on the Algorithmia platform to build, test, and implement models quickly. And then we'll review some next steps for you how to get started and open up for Q&A. So last year, Algorithmia surveyed more than 500 data scientists to get a pulse on the industry. What we found is that a great majority of data scientists' time is spent on everything else except data science. 75% of the time, your data scientists are spending time on infrastructure and process instead of building models. And that's a waste of data scientists' time, reducing productivity and making them unhappy. And to be honest, they probably aren't the right people to be doing the other work anyway. In the same survey, we took a deep dive into what specifically was causing the most friction. And the top three issues were 30% of the time was spent on ML tooling, another 30% of the time was spent on managing their work, but the lion's share of the time was model deployment at around 38%. And let's dig a little bit deeper into some other challenges that exist. So same year, Gartner did some similar research, and they found that deploying models into consumable state where business apps could consume them was the biggest problem. In fact, it was actually more of a problem than internal politics or poor planning. This is a famous research paper that Google published a few years ago about the hidden technical debt in machine learning systems. And Google warned that it is dangerous to think that these quick wins are coming for free. So using the software engineering framework of technical debt, we find that it is common to incur massive ongoing maintenance costs in real world ML systems. And we explore several ML-specific risk factors to account for in system design. And these include boundary erosion, entanglement, hidden feedback loops, undeclared consumers, things like data dependencies and configuration issues, and really like things that we're going through now, like changes in the external world, and a variety of system-level anti-patterns. Algorithmia makes software that closes the gap where people, technologies, and the goals of an organization. And this is about a single unified platform that creates ownership, accountability, and the ability to do something bigger and better, which is why Algorithmia's vision is to free developers and data scientists to deliver intelligent applications. Algorithmia aligns your people with your technology so enterprise businesses can move faster, drive innovation, and achieve more. Algorithmia is a machine learning, operations, and management platform that empowers teams and organizations to deploy models, connect to different data sources, automatically scale model inference, and manage the machine learning lifecycle of a company-wide portfolio across your business in a single environment. And this is the bucket that we fit in right here. So you'll see several capabilities that we offer, and this is the part that we manage and orchestrate. Digging into a little bit deeper into some additional challenges that Algorithmia help you solve. Machine learning iterates at a much different life cycle than traditional software. With traditional software, iterations often based on new features, bug fixes, performance enhancements, which are often optional. In machine learning, the output is an evolving ecosystem, right? So inference is made on the interaction of your code or models with live, often unpredictable data. And interactions with new data can introduce model drift and affect accuracy, requiring constant model tuning and retraining. As a result, machine learning iterations are faster and more frequent than traditional app development workflows. And this places a greater demand on versioning and other operational processes and requires a greater degree of agility from DevOps staff, right? So machine learning is about selecting the right tool for a given job. So depending on the use case, a data scientist might choose Python R or Scala, or another language to build one model, and then a different language for a second model. So within a given language, there are numerous frameworks and toolkits available. So you have TensorFlow, PyTorch, scikit-learn, all work with Python, but each is tuned for specific use cases and operations. And each outputs a slightly different type of model. And then there's a different layer. The harder creates additional dependencies, and scaling that is expensive and difficult. To solve this challenge, many organizations attempt to snapshot an environment, right? So they build these deployment systems that support the tools in current use. And inevitably, those platforms are out of date before they launch, and tools are constantly coming into or falling out of fashion. And data scientists embrace their instinct to experiment. A number of training frameworks include their own deployment tools, and unfortunately, some of these presuppose a reliance on a single set of tools and languages, which is the opposite direction in which data science is going. So the Agile methodology is based on this idea of iterative and incremental development instead of a linear approach, right? So it doesn't build an entire system at once, but rather develops incrementally. And this methodology is appropriate when applying it to machine learning workflows, as iterations are faster and more frequent than traditional app development workflows. And this places greater demands on versioning, model governance, security, and other operational processes, and requires a greater degree of agility from DevOps staff. So now we have a conceptual understanding of how machine learning iterations in general are faster and more frequent. I want to demonstrate how data scientists and engineers can work with these agile principles on Algorithmia to build, test, and implement their models quickly. I'm going to review an actual Algorithmia solution to get a more contextual understanding of some things you can do. So the example that I'm going to walk through is a common use case. So imagine there's a existing machine learning workflow that collects positive or negative sentiment from people to then take some sort of action, whether it's understanding sentiment from social media, reviews on a site, or survey feedback. And then you need to do something with that information. Perhaps you need to follow up with customers when there's a negative sentiment to resolve issues and allow a team to provide faster response times. So over the years, applications have become more composable, right? So built from multiple components rather than a huge code base. So this monolithic code base. Service-oriented architecture and microservices have moved application development from this huge monolithic code base toward a more modular assembly line. And even more than traditional software development, machine learning is about choice. So choosing the right framework, the language, and the hardware that you want to use for compute. And when you've built the model, that model and all its dependencies get changed into a pipeline of other models, each with their own ecosystem. So in this example, imagine a public relations firm is looking to identify news reports critical of one of its customers, and they might use the following pipeline. So the first step is, in this V1 example, is to load a text file. Identify the language of that text with this language identification model that's using Python and scikit-learn. Translate non-English text to English. Prepare the text for sentiment analysis with a vectorization model. And finally, use this sentiment analysis model to score the text and return the result back to the user. So as you can see with ML-enabled applications, the core logic, right, the inference is generated through this pipeline of interconnected models, often written by different teams and using different languages and frameworks. And in this specific version, let's call it V1, right? It takes text files. But let's assume we want to modify this pipeline to take in other documents, like PDF files. So taking that version 1 of a model, imagine we get a request in Jira or Trello, which kicks off a new development task to adjust this model to not only take text files, but also take in PDF files or images. And our goal is to present a microservice API for application use, which uses this new version, okay? So I'm going to show you how we can then edit this existing code on my local machine. I'm going to push my code through GitHub, which is going to create a microservice on the Algorithmia platform, which is then accessible via an API. And while working in Jira or Trello, we could create additional tasks to test the API we've created before deploying a version model with these additional capabilities, which is to accept additional document types. So hopefully you can still see my screen here, and I'm gonna move over. Hopefully this still works. All right. So, oh, let me go back over here. If I go to algorithmia.com, this is where my model currently lives, in this model centralized model repository. And this is where a company-wide portfolio models are stored. And users can, if you have access to a specific model, you can use this model in production and pull them in, look at documentation, see how they work. Here's that current model that exists, and this takes a text file and gets the sentiment out. And I can run this model live from this landing page. So in this directory, I have two files. I have one PDF file and one text file. But this specific version is going to skip text files and only going to process. It's going to skip PDF files. It's only going to process text files. So now it's actually taking this model, loading it, calling the API to be able to run it. Let's give it a couple seconds here. And there you go. So there's a file that loaded this text file, and there's the average sentiment that pulled out. So imagine that we're ready to go and edit this code. We actually have, we came out recently with GitHub integration. So this specific algorithm is versioned, and the source is stored on GitHub. But really, what's going on is that any commit or change that happens on GitHub then it gets reflected on our platform. And here we go. So I'm going to go ahead and git clone this repository locally, and I'm going to copy the Git repository. Now, typically you can just use the console for this, but I'm just going to use this ID for this. I'm going to clone this repository locally, and I'm going to specify the path where it's going to live right here. And it's cloning that repository locally, and now I can edit the code and change it. So this specific sentiment analysis pipeline is, like I said, only taking PDF files. But I've tested and run my code that actually does the OCR. So I'm going to copy paste the new code in. I'm going to save it. All right, and now this code I can commit this code locally. So I'm going to go ahead and do a shift. I'm going to commit it via my IDE over here. So I can add in the commit comment. So adding capability to and then that commit comment is going to be added. And now I'm going to do a git push. So I'm going to do a git push to GitHub. And I could do this from the console, but I'm just going to use this ID here as well. And you'll see a little pop-up on the bottom right that says pushing my local commits to GitHub. And there's pushing my local commits to GitHub. So if I go back to GitHub, that change that I just pushed, that I just updated, will show up in this comment right here, free right there. So that commit was just added there. If I go back to Algorithmia and look at the builds that it's pulling in, so anytime with our GitHub integration, any change or push to GitHub, our platform automatically containerizes and provides you that scalable API for this specific model and abstracts that away from you. So here's that build that's coming in, that git hash for that build that's coming in. And I can go on this git hash and I can test the model before I put it live. So here, all I'm going to do is just paste this sample input where I have those two files. I have one text file and I have one PDF file, and then they contain the same text. So I can send it this directory where that file is, where those files are. It's going to iterate through those directory and pull those files for scoring. So we should see that it takes in those two files and provides me a sentiment out. So there we go. So the text in the files is, I really like Algorithmia, and the average sentiment that I pulled out is 0.47. And there we go. There are my two files. They like that PDF and like that text. So once I'm comfortable and I've tested, and we have ways that you can pull in with our APIs, you can pull in this workflow into a CI/CD tool. You could use Git Actions or Jenkins. So I'm just going to go ahead and publish this so that the version 2 is now accessible. So now I'm going to say for this specific release note, to publish this API endpoint, I'm gonna call this, adding OCR capabilities, click on continue. I can paste the sample input so that another user in the future can test it out and see how it works without having to compile any code locally. So here's that sample out that includes that like text file and the sentiment for both those files. I'm gonna go click on continue, and then I'm gonna provide the semantic version for version 2, the new version that gives me this new capability. And I'm gonna go ahead and publish this. So now that it's published, we're gonna go back to the landing page, and this version is now accessible. Version 2 is now accessible to be called. And I can test the operation live here. And then we provide you these 14 language steps. So even though this is an algorithm that we wrote in Python, and each of these pipelines are written in different languages and frameworks, we can then take any one of these stubs and drop it into an application and use it in production. So in this case, I'm just going to copy paste this stub from Python, and I can actually call this API locally from my machine. So on my machine, I actually have an example here that I can run this. So this is testing that pipe. So here I had that version 1. If I had this version 1, our platform not only provides you an API for models, we provide you a scalable API for every version of those models that you can call independently. Enables A/B testing and backward compatibility. So I'm going to click on one over here. This is my version 1, as we showed before, and it's only going to do text files. Here's that text file. And now I can call version 2. I can change this to be version 2, right? And then run this. And now we can call that new version that has this additional capability. And there's the result out for a PDF file and the text file out. So all this was orchestrated by our platform, right? So our platform has this integration with GitHub. A push to GitHub is then reflected on our platform, and we containerize and manage that lifecycle of your models once deployed, okay? So let me go back to the presentation here, and we can wrap up a little bit of our talk. So to review what we've demonstrated, we've showed how data scientists and engineers can work with these agile principles on Algorithmia to build, test, and implement models quickly as scalable microservices, okay? I was able to take this workflow, push in my new code using the frameworks and languages of my choice. The algorithm was then managed in a catalog and versioned. We could run benchmarks, A/B test, and also add this workflow to another pipeline. And this specific sentiment analysis algorithm was then served and efficiently scaled as a scalable microservices. The deployment and management of my models and algorithms are all orchestrated by our platform. Productionizing machine learning is a massive challenge for business today. So something like 60% of machine learning projects never get into production because of a myriad of issues. There's a large gap in tooling available to the market today, and the needs companies have to properly manage ML and AI in a repeatable and scalable way. Continuous deployment and integration are standard practice in the world of software development, and machine learning is no exception. So you need robust CI/CD workflow to ensure that your latest models are deployed efficiently and correctly into production. Algorithmia supports deployment and redeployment by the Algorithmia API, and this is easily integrated into CI/CD tools such as Jenkins or GitHub Actions. With Algorithmia and your favorite CI/CD tool, your models are deployed as soon as they're ready and can be instantly redeployed whenever an approved algorithm is available. Algorithmia is built to enable governance, management in real time through logging, auditability, and chargebacks. And this helps to achieve better outcomes for your business objectives in your ML practice. We're backed by enterprise-grade security and best-in-class tooling, which gives you full control of mission-critical ML applications and enables your teams to scale with a reduced risk, which your DevOps teams will prefer. And finally, Algorithmia allows you to increase effectiveness, eliminate silos, create velocity, and scale your ML initiatives with confidence, all from a single platform. So to wrap up and start off a little bit of a Q&A here, please visit us at algorithmia.com, and we actually have this blog post showcasing this GitHub integration, documenting how you can use Algorithmia to enable your CI/CD pipelines. And we also have a white paper about machine learning infrastructure that you can also download that link. And if you have any challenges that you want to talk through and brainstorm ways to productionize your machine learning algorithms, happy to help. And here's my contact info, jbrache@algorithmia.com. That said, I'm going to open it up to a little Q&A now, and let me see if any questions come through on the window here. So there's a question here: is GitHub a requirement? And the answer is no. The question is GitHub a requirement? Can I use my local Git repo like Bitbucket? And the answer is yes. So, you can use your existing Git repo, and we have these management APIs that you can use to deploy from your own Git repo and push your code to Algorithmia. Algorithmia has its own Git repository. So with these APIs, you can just basically do a Git clone to Algorithmia, and then your model will be served and managed by our platform. And I also have a Slack, if I want to get messages on Slack. So we have a question here: how can I leverage Algorithmia if I'm using SageMaker, something like SageMaker? So that's a great question. For some, and Algorithmia as a platform, we want to provide you a platform that is agnostic to a training source or other tools. So what you would do is that you would still use SageMaker for training and building your model and choosing the right model for your use case. And then once that model needs to be put into production, you can export that model from SageMaker, right? So in this case, you might take that model and create a pickle. You would create a pickle from that model and load that pickle in Algorithmia. What Algorithmia is going to do is load that pickle and provide all the scoring. So it'll load the pickle, API request comes in, it'll load the pickle for scoring, pass it a payload, and then return the result out back to the user. That makes sense. So let me see if there's any additional questions here. Where can I add documentation? So that's a great question, and your documentation, and it would be basically a readme.txt file. If I go back to the platform, any change or update in a readme.txt file will be pre-printed. So anybody that has access to a specific model or group will be able to look at documentation that an author has written, talking about the inputs, how to pass a payload, what the outputs are, what the limitations are, those sorts of things. And then I see a request here. Can I see the JavaScript API call? Sure. So if I go back to the sentiment pipe over here, there's a stub for JavaScript. So you can call this model just by loading, just by doing this JavaScript, by loading our library, this JavaScript library, and you would authenticate with an API key. So all of we track which user calls, which algorithm, how many times, and really provide the security around calling models and controlling who has access to those models and what those models have access to. So here's a little code snippet that you can pop into JavaScript and call it from JavaScript. And then here's another question.
I'm so sorry, Jose, we should finish. Thank you very much for these amazing talks, dear attendees. We are grateful for those who have attended this session, and we'll provide the survey at the end. Have a great day ahead.
Thanks, everybody.